This is the solution for the mock exam for integration and solids. You are asked to calculate the amount of paint necessary to paint the side of a new high-speed rail train. The rectangular part of the train is 3.5 meters high, and the curved portion is modeled with the function y equals 3 log x plus 0.5. The area between the x-axis and the piecewise function below indicates the area to be painted. So basically that means that between the function, remember piecewise function is a function made up of two or more other functions, and so this function is a piecewise function because it's made up of a straight line for the right side and a curve on the left side, and the x-axis. So basically this is the area that needs to be calculated. And the first step, it says to find the x-intercept of the curve, which is this point here. Okay, so basically what we need to do is we need to put this equation into the calculator and then use second calc 0 to find out what the x-intercept is. It looks like it's between 0 and 1, but we can't see the exact value here. So let's put the function here. It's 3 log x. It's been a long time since we used log, right? Plus 0.5. And then we're going to graph it. And we can see we get the same curve here. And now what we're going to do is we're going to find this x-intercept. The way we find the x-intercept is we use second calc 0, which is number 2. And then the left bound, I don't see the cursor anywhere, so I'm going to move, oh, there we go, there's the cursor. And then I hit enter. And then I go to the right side of the x-intercept. And I hit enter. And then it says to guess. It doesn't matter where I guess because there's only one x-intercept there. And the answer is 0.681. So I'm going to write that down. Okay. And then part B says, write down the integral expression for the area between the x-axis and the curved portion. So what that is talking about is just this section here, right? Just the green shaded part is the part that's between the x-axis and the curved portion. I'm ignoring the rectangular part. Okay, so how do I write the integral expression for this? I need three things. One is I need the function, which I have there. The other is I need the left boundary where the curve starts on the left side, and of course that is 0.681. And then I need the right side boundary, which is 10. Okay, so let me write out the integral expression. Remember, the integral expression starts with this long s on the left side. The left boundary goes here, 0.681. The right boundary goes on top. It's 10. And then inside, I'm going to put the function, which is 3 log x plus 0.5. And then how do I end this mathematical sentence? I put dx at the end. And when you put this in the calculator, you actually put parentheses around it, but in normal math notation, the parentheses are not necessary. Okay? So we're looking for, besides the overhead, which is like, this part and this part, this is like basically saying this is an integral. This is finding the area between the x-axis and the function you're giving. The other three things you need are, you need the left boundary, which we calculated in part A. You need the right boundary, which is obviously taken from the graph. And then you need the function itself, which we got from the specified function. Okay, now that we have this expression, we kind of know what's coming next. It says find the total area of the side of the train to be painted. Okay, so when they say the total area, they mean the entire yellow area, and the difficult part is the green part, which we're going to do with the calculator. Okay, so let's do the green part. There's a couple ways to do it. I'm going to show you both ways. The way you would do it on the calculator is, and I like this way because it colors in the part you're doing, so then you do second calc, and then you do integral, which is option 7, and then you give it the lower limit, which would be 0.681, 0.6 0.81, enter, and then you give it the upper limit, which is 10. 1, 0, enter. And then it colors in the area that it's calculating it for, and it says it's 22.85, so I'll say it's 22.9. So the yellow part is 22.9. So this part is 22.9. What about the rectangular part, which is between 10 and 15? You could use an integral to calculate this too. The way you would use an integral is you would write down the integral from 10 to 15 of the function. And how high is this function? Or what is this function? This function is a horizontal line at height 3.5. Remember, it said that the height of the train is 3.5 in the rectangular part. So you would put 10 to 15 and 3.5 dx. If you did this in the calculator, it would give you the answer. But this is a rectangle, so you don't need an integral to calculate the area of the rectangle. You could just multiply length times width, so be careful. It's not 3.5 times 10 or 15. You have to find the difference of the two, right? The width of this rectangle is 5, so it would be 3.5 times 5. Okay, so let's find out what that is. And then I'll go back and show you how to figure out the integral using another method. So this would be 17.5. Okay, so the total would be 22.9 plus 17.5, which is equal to 40.4. Okay. Now let me show you the other method of figuring out this integral here. So the way you would do that is you would go to math, and then you would go to number 9, which is f function integral, and then you would just fill in the boxes here. So 0.681 and 10. And inside the function, I would put 3 log x plus 0.5. 3 log x plus. Oops, I need to put another parentheses because the log function needs a parentheses too. Plus x plus 3 log x plus 0.5. And then I put an x over here. Enter. And it gives me 22.9 again. So it's the same answer, but it's a different method. What is the advantage of the other method? The other method, since it colors in the part that you're integrating, you can kind of check your answer. And here, there's no visual to it, right? Okay, let's go to the next section. So this is a solids problem. The right pyramid shown in the diagram has a square base with sides of length 40 centimeters. The height of the pyramid is also 40 centimeters. So find the length of OB. So OB is this slanted height here. And I think that the best way to go about these problems that are in 3D is to draw the relevant triangle on the 3D picture and then take it and flatten it out in another drawing on your paper. So I'm drawing the same triangle here, but I'm drawing it flat so that it's not in 3D. And if I do that, then it's easier to see that this is a right triangle, and what the line that, or the side length I'm looking for is OB, which is the hypotenuse. And then I can label the sides with any of the sides that I happen to know. I do know that the height is 40. Do I know anything else? No. So now I need to try to figure out this side here, right? If I figure out this side here, then I have a chance of figuring out the hypotenuse. The first step to doing that is to take a look at this triangle here, right? This triangle here is instrumental in figuring out the length PB because this is also a right triangle, right? This is a right triangle, and it's also like if you look at the base from the top, you have a base which is perfectly sliced into 4 identical triangles that all have the same measurements, right? So, or that have all the same angles too, right? And actually, if you were to try to figure out the length of OB, which is this line here, right? You can see that you could do that because you know that this angle is 45 degrees and this angle is 45 degrees because this triangle is like all the side lengths, the leg lengths are the same, right? So the hypotenuse is 40, and you know that this side and this side are both the same length. Let's say that it's x, okay? So we can figure out the length of x using SOHCAHTOA, for example. So we could do, so let's say that this is angle theta, and we know that the sine of theta is equal to, well, let's say cosine of theta, because, and I'm going to redraw this triangle so that it's the way you normally would see it. Okay, so then I've drawn it flat, and then I put the red line here, and I know that the hypotenuse is 40, and I know that this angle is 45 degrees, right? So if I put cosine, because SOHCAHTOA, adjacent over hypotenuse, I would put cosine of 45 degrees equals the red line, which is my x, divided by 40. Okay, and then in the calculator, and then I'm going to solve for x, okay, which is this x length is the length of I don't know what you call it. Oh, p, there. So it's the length of p, x is the length of pb, right? Okay, so let's do that. So that would be equal to, let's find the cosine of 45 degrees. Oh, I need to change the mode. Make sure you change the mode to degrees because we haven't done that yet. Your calculator maybe already has it in degrees, but if it's been reset, you got to be careful. So cosine of 45 degrees is, no, it's not. Didn't change. Degrees. Let's try that again. It's actually 0.707. Okay, so we have 0.707 cosine 45 degrees is equal to 0.707. So now let's rearrange it so that we have x isolated here. So x is equal to 40 times 0.707. So it's 28.3. So we know that this x value, or PB, is equal to 28.3. Now that we know that's 28.3, now we can use SOHCAHTOA to solve for the hypotenuse. Actually, not SOHCAHTOA. How do we figure out the third side if we know two of the sides? Pythagorean Theorem, right? So let's set up Pythagorean Theorem. It would be 28.3 squared plus 40 squared equals OB squared. Let's say the hypotenuse squared. So 28.3 squared plus 40 squared equals 2,400, and then we'll just take the square root of that, and it gives us 48.99, which rounds to 49.0. Okay, so the length OB is equal to 49.0. Okay, so that yellow line is 49.0. Okay, then it says find the size of angle OBP, and OBP is this angle here. So if we had used SOHCAHTOA to solve the previous one, we might already know OBP, but we didn't know that we needed that. So now we have all four sides. We have this is 49, we have this is 40, and we have this is 28.3. So now we can use any number of methods to figure out this angle. Let's use sine of theta. So the sine of theta is equal to the opposite over hypotenuse because so katoa so. So sine of theta is equal to 40 divided by 49. And we take the inverse sine of both sides. So 40 divided by 49, by the way. 40 divided by 49 is equal to 0.816. Okay, and then I'm going to take the inverse sine of both sides, so it would be theta equals the inverse sine of 0.816. Inverse sine 0.816 is 54.7. So the angle that we're looking for is 54.7 degrees. Okay? And then the final thing says, find the volume of the pyramid. The volume of the pyramid we find by using the formula. And the formula, I believe, is, if you look on the formula sheet, is volume is equal to 1/3 times the base of the area of the base times the height. And the area of this base is pretty easy because it's a square, right? It's equal to the side squared, so it'd be 40 squared. Each side is 40. So that's 1600 for the area. And so we would put that for A. And then we would multiply it times the height. And the height is also 40. Oh, don't forget 1/3. So actually it's 1/3 times 40 times 40 times 40. So it's actually 40 cubed. And then we divide by 3. 21,333. Okay? So that's it for that one. Just to review the steps that we did, the first thing is they asked us for this yellow line, the length of the yellow line. And this is challenging because we don't quite have enough information directly to find the yellow line. We would also need to have this blue line here. We need to know PB in order to figure out the yellow line, right? So what we did was we used this triangle here, which is a special triangle because both these blue lines are the exact same length, okay? And so we could use SOHCAHTOA because we know that this would be a 45, 90 triangle, okay? Let me just show you one other way that you could solve for this blue line here, even if you didn't see that it was a 45, 90 triangle. I think that most people would see that actually all these blue lines here are the same length, right? Because this is a square pyramid. So if you know that all these blue lines are the same width, then what you would do is you would say, I'm going to use Pythagorean Theorem, right? So you have x and x for your two legs, and then you have 40 for your hypotenuse. You could use Pythagorean Theorem to solve for x. You could go x squared plus x squared equals 40 squared, right? And then you say, okay, that's 2x squared equals 40 squared, which is 1600. And then you would divide both sides by 2, which would give you 800. And then you would take the square root of 800. And that would give you 28.3, just like we got before. Okay? So that's another way to do it without realizing that all these blue lines are the same length. Or without realizing that the blue triangle is a 45, 90 triangle.